Here's a pretty straightforward equation to solve. Square root of 3x plus 4 minus 5 equals to 0. Alright, now I'm going to isolate the square root part by moving the 5 to the other side. And we do that through addition. So I add 5 to both sides. And I have the square root of 3x plus 4 equals to 5. And from here, we make progress by squaring both sides. So I'm squaring a square root term only on the left side, and that will remove the parentheses, so I end up with 3x plus 4 equals to 25. And then, let's see, we'll subtract 4 from both sides. This will give us 3x equals to 21, and then divide by 3, x would equal to 7. So there we go, there's our answer. Now that would be fairly easy to check. If I put 7 up into here, I'd get 21 plus 4 is 25. Square root of 25 is 5. 5 minus 5 is 0. So there's your answer. Alright, well, let's do another. And let's see. Here it is. Solve square root of x plus 5 plus 4 equals to 0. Now I look at that immediately and say there's no solution to this one, because if you move the 4 to the other side by subtraction, it has to be done by subtraction, then we get the square root of x plus 5 equals to negative 4. And as we discussed in the last video, square roots can only be positive, or could be 0, but can never be negative. And so there's no answer to this, no solution. And I did talk about this before, but I just wanted to reinforce it one more time. We could continue to work on this problem by squaring both sides. If I squared both sides, I would get x plus 5 equals to positive 16. So x would be 11. But if you plug 11 up here, you're going to get 11 plus 5 is 16. The square root of 16 is 4. 4 plus 4 is not 0. So we get a false solution. Alright, so be alert to that. And as long as you got it in your head, square roots cannot be negatives, then you know, you won't make a mistake. In this case, it's no solution. Now, it's okay to take the square root of a negative. We've done that before. Square roots and negatives give us complex numbers, but square roots are never equal to negative numbers under any circumstance, and it's simply because of the way the square root function is defined. All right, I'll work one more problem. Solve cube root of 2 minus x plus 3 equals to 0. Alright, and again, I'm going to use the same strategy. I want to isolate the radical. In this case, it's a cube root, not a square root. So I'm going to isolate it by moving the other term to the other side. So I end up with the cube root of 2 minus x equals to negative 3. And it's okay if a cube root is negative, because the cube root of a negative number is negative. So third roots or odd indexed roots are okay. So here, if I raise both sides to the third power, that's how we're going to eliminate the cube root. Cube root cubed eliminates the radical sign, and I end up with 2 minus x equals to, and here I've got negative 3 times negative 3 times negative 3 is negative 27. And then we go from there. I think x would be 29 in this case. If I subtract 2, minus x would be negative 29. So x would be positive 29. And there you go. And that's verifiable. If you put 29 up here, you get 2 minus 29 is cube root of negative 27. That's negative 3 plus 3 is going to be 0. Alright, so there's some simple examples using radicals, or cube roots and square roots and so forth. And it gets a little more complicated when you have two of those in an equation, and things get mixed up a bit.